Hello, I am Akash. I am a PhD candidate at Ontario Tech University at Automotive Center of Excellence. We do a lot of testing of batteries and the BMS for EV applications. In this paper, we have proposed a real-time CAN data acquisition and visualization system for physical to virtual twinning of automotive battery management systems. Here is my co-authors Mohit, Sharma, Chandan, Chetri and Professor Sheldon Williamson of Ontario Tech University. Here is the architecture of the online BMS system. So as you can see from here, so it includes a NXP BMS, a 14-cell battery module and a STM microcontroller to collect the temperature data, and all the data that we are collecting, it is going to InfluxDB for storage and online visualization. So the overall architecture includes a 14-cell battery module and the BMS of NXP. So it has CAN enabled. So this module data including voltage, current and temperature we are getting through this NXP BMS, and for specifically for temperature we are using a STM board that is going through the CAN bus. Like this is the multi-link a universal programmer that we are using to program the NXP BMS, and all the data that we are getting from the CAN bus we are transferring it to a Python based script to decode the data. So as I mentioned, the raw CAN data that we are getting from CAN bus, we are transferring it to a Python based script, and this Python based script is running in the cloud as well. So to read all the raw data, so it is decoding all the data through the Python code. This is all custom made for this particular application, and which is very flexible to use for any automotive grade application. We are getting in the screen, and similar these data through online platform we are transferring it to InfluxDB to store and visualize and analyze the data, and later we will utilize this data for state estimation and control operation. Demonstrate the capability of our online monitoring and visualization system of the batteries and the BMS. You can see from the graph that the real-time battery current is 0 now. So moment you will start charging, you can see that reflected in the online monitoring system. So immediately you can see from here that current is changed to 2.5 amp. This is the electrochemical impedance spectroscopy system. As you can see from the graph that this is the aging parameters of the battery. So what importance is this data we can keep in our online server, and we can anytime we can visualize and we can analyze those data for second life applications of lithium-ion. I would like to thank IEEE IES for the SYPA, and also I would like to thank my co-authors Mohit Sharma, Chandan Chetri and my supervisor Professor Sheldon Williamson for giving us the opportunity to